Students, in this class we will learn to understand what is 0 raised to the power 0. Now, you all would have learned this formula that a raised to the power m is nothing but a is multiplied m times. Now, when m is equal to 2, the understanding is you have a being multiplied twice. So that is the reason you get a squared. Now when m is equal to 3, you have an understanding that a is multiplied 3 times. And m is equal to 4, the understanding is a is multiplied 4 times, and so on and so forth. Now we all would have learnt the formula that a raised to the power 0 is equal to 1. Of course, we are not going to look into the proof that a raised to the power 0 is equal to 1, but we are going to look into the aspect of what happens when a is equal to 0. That is the important fact. Now, from binomial expansion, you would have known that a positive 1 raised to the power n is equal to sigma k is equal to 0 to n nk of a raised to the power k times 1 raised to the power n negative k. This is a standard formula. You would have known this. Now, the question is, what happens when a becomes equal to 0, right? Along with n being equal to 0. So let us first understand what happens if a is equal to 1 and n is equal to 1. Now clearly this would mean a raised to the power 1, and that is going to be 1 raised to the power 1, which is equal to 1. Now if I were to take the value of a to be as, say, 0.9 and the value of n to be as 0.9, then a raised to the power n is going to be equal to 0.9 raised to the power 0.9. This value would be approximately 0.909. Now when I take a to be as 0.8 and the value of n to be as 0.8, and I find out what is a raised to the power n, which is going to be 0.8 raised to the power 0.8, the value would be approximately 0.836. Now moving on, if I were to take the value of a to be as 0.7, n to be as 0.7, then a raised to the power n is going to be 0.7 raised to the power 0.7, which would be approximately 0.779. Now if I were to take the value of a to be as 0.6 and n to be as 0.6, then a raised to the power n is going to be 0.6 raised to the power 0.6, which is approximately 0.736. Now if you make an observation, the values are actually going down. Okay, now let me take a to be as 0.5 and n to be as 0.5 and find out what is a power n, which is going to be 0.5 raised to the power 0.5. Now the value would be 0.707, approximate value I am using. Now if I take the value of a to be as 0.4 and the value of n to be as 0.4, then a raised to the power n is going to be 0.4 raised to the power 0.4, which would be approximately 0.693. Now if you were to take the value of a to be as 0.3 and n to be as 0.3 and find out a raised to the power n, you will have 0.3 raised to the power 0.3, which is going to be 0.696. Now let me bring your attention to a very important observation. If you were to take a to be as 0.2 and n to be as 0.2, then a raised to the power n would be 0.2 raised to the power 0.2, which would be approximately 0.729, an approximate value. Now, if you were to take a to be as 0.1, n to be as 0.1, and find out what is a raised to the power n, it's going to be 0.1 raised to the power 0.1, which would be approximately 0.793, something like that. Now, if you would have noticed here, from a being equal to 0.3, the values are suddenly increasing. Now, not only that, if you were to proceed by taking the value of a to be as, say, 0.00001 and n to be as 0.00001, you would find this value is approaching 1. So it would be approaching 1, but it will not be equal to 1. Okay, so the idea, what I'm trying to show you here is binomial expansion. If I were to use the binomial expansion formula, we know the binomial expansion formula to be as x positive 1 raised to the power n, which is equal to sigma k is equal to 0 to n of nk times x raised to the power k 1 raised to the power n negative k. Now, this is approaching 1. So, if I were to take a raised to the power n, which is nothing but, if I were to assume a to be as 0 and n to be as 0, this formula can only be true if I take the value 0 raised to the power 0 to be equal to 1. So that is an important point you have to know. Now, the value does not hit 1, but it is going towards 1. Okay, you can very well check it out. You can just substitute the values of a and substitute the values of n and try to increase as many zeros as possible before 1. You will clearly find the value is tending towards 1, but it is never equal to 1. Now, the point what I'm trying to tell you here is, if I don't take 0 raised to the power 0 to be as 1, then this cannot be true. Okay, that is an important point. So the binomial expansion will be true only if I take the value as 1. But on the contrary, this is a very important observation you have to know. If you are using the concept of limits, and if x were to approach 0 from the right side, then 0 to the power of x will be equal to 0. But limit x tending to 0 from the left side, 0 raised to the power x will not be 0. It would be simply undefined. So, by definition of limits, a limit can only exist if limit x tending to 0 positive of 0 raised to the power x is equal to limit x tending to 0 negative of 0 raised to the power x. Okay, this has to be true. And other limits of the form 0 raised to the power 0, they can have any value. So have that in mind. The best example would be limit x tending to 0 plus x raised to the power 1 over ln x. The value here is e. So what is limit x tending to 0 of x raised to the power x? What can we say about this? In other words, what is 0 raised to the power 0? Now, if you are viewing the entire question in terms of limits, then the best answer should be undefined. This is the best answer. Now, you should also understand that mathematics is not an exact science. So, for the sake of convenience, mathematicians take 0 raised to the power 0 to be as 1. Now, just for the sake of convenience. Now, if we do not take this, the entire concept of binomial theorem would fail. So have that in mind. The underlining point is, from limit concept, from the limits point of view, 0 raised to the power 0, the best answer is undefined.